Hello, integrated science class. So now I want to talk about how the understanding of electricity changes. So Benjamin Franklin had thought about electricity as a kind of imponderable fluid. And if you remember from our discussions of heat, that was also how people in the 18th century thought about heat at the time, as a kind of fluid that they called caloric. But you'll remember that this understanding was abandoned as heat became to be understood in terms of this broader category of energy that gets developed. And you'll see something similar happening with the history of electricity. So you see the study of it going from these sort of qualitative descriptions based on fluids to a much more quantitative mathematical description in the 19th century. And you also see it going from being this isolated phenomena, that is this sort of strange effect that was studied by itself, to being unified with the rest of physical forces, to being part of a much bigger explanation. So now we'll head to France, where a man named Charles Coulomb invented a device called the torsion balance, which was able to measure these electrical forces much more precisely than they'd been able to be measured before. So the way the balance works is that there's a long silk string within this sort of long glass section that you can see. So hanging at the end of that string then would be a rod, and at the end of the rod was a little metal ball. So that ball could you could put an electrical charge on that ball. You could see that there's another small ball there, and that one too could have an electrical charge on it, which would mean that these two balls would be sort of either attracting each other or repelling each other. So what Coulomb wanted to do then was to be able to measure how much they repelled each other by measuring how much then that force was twisting the string, how much the bar was, sort of what angle that bar was turning through. And what he concluded, he was able to get very precise data, and what he concluded was that the force between these two electrical charges was an inverse square law, much like the force of gravity that Newton had uncovered. So you can see the formula here that I'm sure you've seen before in your book. So the force between these two charged balls was equal to K, a constant, with the Q1, the charge of one ball, and Q2, the charge of another ball, multiplied by one another. And then all of this was divided by the square of the distance between them. What I want to do next is run through a series of experiments that changed the way that people thought about electricity and showed that electricity was connected to things that they hadn't thought that it was connected to before. So the first of these was done by an Italian, Luigi Galvani, in 1792. What he did was he hooked up frogs' legs. So he took dead frogs, cut off their legs, but left the nerve endings coming out. And then he hooked up these nerve endings to an electrical apparatus. So what you see here, you see the wheel, which is used to sort of generate a bunch of static electricity. You see the sort of disembodied hand, which is drawing the electricity off of that. And then that electricity is being put onto the sort of nerves that are hanging out of the frog's legs. And what he found when he did this is that the legs would start kicking in such a way that it looked exactly as if, sort of the living frog, the frog was alive and kicking its leg. So what this indicated to him is that there was some sort of connection between electricity and the processes of life. This, by the way, was the fact that inspired Mary Shelley to write Frankenstein. So it has all sorts of repercussions, but the one we'll focus on here is that it pointed that electricity was not just this isolated phenomenon, but was connected to other things like whatever it was responsible for life. It was in the 19th century that people began to figure out that electricity was also somehow related to magnetism. So magnetism was this other force that had been known for hundreds of years by this point. People were very familiar with the lodestone, as they called it, which was this stone which sort of always directed itself towards the north. This was the basis of compasses. People had been using compasses for a very long time to help navigate by this point. But it was only in the 19th century when they began to figure out that electricity and magnetism were somehow connected. So the first hint came in 1820. It was a Dane, Christian Ørsted. And what he figured out is that if he had a magnet that was placed near a wire, and whenever he set up a current that would start going through the wire, the needle on the magnet started to wiggle back and forth. Eventually, he figured out that what was going on whenever you had a current going through a wire, it was setting up this circular magnetic field around it. Meanwhile, over in France, you also had a French physicist, André-Marie Ampère, who was inspired to start working on similar things. And what he figured out is that if he had two parallel wires and he sent currents through them, they essentially acted as magnets towards one another. That is, they attracted and repelled one another the same way that magnets would. So you have, with all this work, so a clear indication that electricity and magnetism are not two separate things, as had been thought all along, but actually seem to be connected to one another. So Ørsted and Ampere had figured out how to use electricity to create magnetic effects. And a few years later, an Englishman, Michael Faraday, figures out how to do the opposite. That is, he uses magnets then to create electrical effects. So what he does is he has he builds two large magnetic coils. You see them over here. So one is very big and has a hole in the center, and the other one is smaller and actually fits inside. And so he starts moving the smaller coil inside the bigger one. And as long as those two coils are moving with respect to one another, he actually created a current going through a wire. So just by having two magnets moving with respect to one another, it created an electrical current. So this goes on then to be the basis for generators, transformers, motors. It really has an enormous practical component to it as well.